or maybe
Oh yeah, no, it's been really sparse as to.
you should know this.
Um,
You've been lectured. You've been lectured in class. You should know it.
nope.
No. Nope.
We don't get lectures. What are you talking about? What's a lecture nowadays? Come on.
Haven't been to class once for this class.
I know. Give me a sec. I'm just pulling up stuff. Yeah, my math lab is. I mean, it's a great tool. It's just this week it's been really, really sparse as to what they've given us. So.
Yeah.
Okay.
This step. Have fun.
So your question was about the reduction formula? Is that what you're asking?
Yeah, reduction formula in particular, I wrote it down from the PowerPoint because I was like, okay, I don't know. I have not seen this at all in the my math lab yet, and I'm just confused as to when it applies, and I'm probably
Okay.
it's just I'm just confused as to when it applies, essentially.
Yeah. Give me a sec. I'm opening the PowerPoint.
I thought that was on my screen. I was like, what the heck? I didn't click that.
All right. So.
Okay, so essentially it's factoring then.
Yeah, so it's going to be taking two separate functions and reducing them into one. So they've got to have, it looks like, if A is an angle in standard position, which standard position is along the x-axis where basically 0, 1 on the unit circle, right?
Oh, okay, yeah.
Whose terminal sign contains a point AB, which is anywhere along that circle. Then A sine x plus B cosine x is equal to A squared plus B squared sine x plus alpha for any real number x. Okay. So you notice we start with a trigonomic function that's both sine and cosine, but we end with a trigonomic function that only ends with a sine. Okay. So we've got the sine and the cosine, but it reduces to just sine. All right. In order, if A is an angle, okay, yeah, that's what we just. If in order to use the reduction formula, you first need to find alpha. The terminal side alpha goes through the point AB. Okay. So
Okay.
we need to find the angle. Thankfully, with this, we're always working with right angles, so we know one side. What they're doing here is, I mean, you can use any of these to find the angle, I guess. They have right here, they're finding side C, which I guess isn't necessary. Oh, I guess we've got B over C, A over C, or B over A for tangent. So let me move this out of the way real quick so I can look at it. So in a case like this, we have our right triangle. Sorry, I'm not going to draw things perfectly, but we've got B, A, and then C over here. We don't know C, but we need to find this angle. So we need to have alpha. So in this case, since we don't have alpha, we need to find the tangent, the cosine, or the sine. And so in that case, I mean, let's just say we'll do 1, 2. So if we do tangent of alpha is equal to going to be B, so 1 over 2. Or in the other cases, sine of alpha is going to be equal to 1 over the square root of A squared, which is 4, plus B squared, which is 1, is 1 over the sine of alpha is equal to 1 over the square root of 5. I won't go into cosine, but so then we just use to find the angle. Alpha is going to be sine or arc sine of 1 over the square root of 5.
Oh,
Or tangent. So that's just basically finding the angle in this case. So in this, we can go ahead and plug this in to it. So we're going to reduce it just to its basic form. So then it goes kind of into it a little bit more.
okay. So then we found the angle, and now we can start using the reduction formula to
Yes.
reduce the sine plus cosine into something that is more optimized and useful.
Yeah, so it's instead of being a big, long kind of equation, and so in this case, we would have had, it would have been two sine functions. It would have been a sine function, 2 sine x plus 1 cosine x. And they want, so it's just, it says it's to reduce it to just basically one, just to reduce it to one trigonomic function. I'm not exactly sure as to why. It doesn't give a reason why you'd want to do that, but I guess, to solve, it's going to be to solve for x in this case.
Okay.
So we would have, again, that would be the square root of 5. Sine, we've got x, and I need to find the,
Hold on.
you're fine, I'm got to find the arc sine of, or I'll just do arc tangent of 1/2, so 0.5.
26.5 is what I got.
I got it. Yeah, 26.56 is what it's going to be. So we'll just do 26.6. Okay. Let me pull back up my PowerPoint. Oh, I guess they wanted us to do it.
Okay, and then from here we would solve for x.
Well, this is just, I mean, I guess you could if it was equal to, so they have y is equal to, or I guess y is equal to that. We don't have an exact.
Yeah, all they don't want you to solve for x. They just want you to put it into one trigonomic.
Oh, they don't want to solve it.
Form. They don't want you to solve it.
No, it doesn't look like it. Yeah, because even in
function, this is like if you, because you could graph that.
Ooh. Well, I don't have a graphing calculator, so that complicates things, but still.
Yeah, I need to get a graphing calculator, especially if I'm going to be taking calculus next semester.
I've got one. Do we need to graph it?
No, we don't need to. This was just an example of how to do it.
Okay.
All right. I understand a lot more now. I feel comfortable diving into the example problems if you wish to.
I'm okay with that. Unless you guys have any other questions or things that you want to review.
I'm good.
Okay, cool. Well, let me close this, and we'll move on to the actual questions. So,
Awesome. All right.
all right. The following work guides you through solving this equation. Let me copy it over. So we've got tan of 3x plus 1 is equal to the square root of 2 secant of 3x. Okay. Based on the previous problems you have solved, what is the issue in solving this equation? What identity can you use that relates tangent and secant together? What will you need to do in order to use this identity? I need to pull. I don't have them memorized, guys.
Yeah.
So,
So, first of
Fine.
all, let's probably simplify secant into 1 over sine.
yeah. So, okay, let's go ahead, and I need a little bit more space. Square root of 2 is 1 over sine times 3x. Then, I mean, if you really wanted to, you could do...
Oh, I'm sorry. I'm sorry. That's 1 over cosine.
Yes, yes.
Wow, that was a bad mess up right there. Sorry.
No, you're fine.
Yeah. Well,
Cosine 3x. I mean, that would be what I did first off. Oh, wow. I write cosecant instead of cosine. All right. Okay. Okay. Anyways, going back to her. Okay. All right.
So,
Oh, okay. So what they're saying, actually, before even doing anything else, it wants us to multiply them out. So they're basically squaring both sides here. I'm not sure why. Because they're not squared in the first place. Right. But I see where they're kind of going towards, because they want to get to a point where they can use the trigonomic identities, and in order to kind of convert from one thing to another, you need that square. Okay, so that's going to be 2 tan 3x, and then plus 1. All right, it says now that it is multiplied out, use the identity in order to get rid of the secant function and simplify.
so secant.
What, how is she getting rid of secant? Why is it 0 all of a sudden? Because I mean, if we multiply, that's going to be square root of 4 secant squared 3x.
Let's see.
Would it be 2 secant?
Oh yeah, you're right. I mean, yeah. Either way, it's just I just wrote it here. Yeah, it'd be just 2 secant.
Okay. Hold on. Let me go to Google Images and hunt down.
Okay.
hunt down trigonometric identities.
Yeah,
Well,
I found a page of them, but it's way too complicated.
yeah, I mean, because we've got secant squared, which, I mean, if we did that, how would you do that? Why is it even equal to 0, though? So the secant squared
Oh, okay.
x can be equal to tangent squared of x plus 1. That's the function right there. So, I mean, I guess breaking it down even more, that would be 2 tangent squared x plus 2. Okay.
Is it 3x instead of just single?
Well, I'm sorry. Yeah, it would be 3x. It was just working from that. But.
Okay.
All right. So tan squared 3x plus 2 tan 3x plus 1. Okay. I mean, we can move all of this over. 3 do minus 2 tan squared x minus 2. That would give us negative tan squared 3x plus 2 tan 3x minus 1. Is that what she had? I didn't even look at the... No, that's not.
Oh, great.
How did she get 0?
I'm always just of the solution sheet.
Yeah, I know. I mean, we've ran into quite a few of them where they've been wrong.
So from number great. Okay. Hold on. Oh.
What other identities do we have?
Let's see. Didn't she give us one that's like a page? Or like fits in a page?
Maybe.
I'll look.
I haven't been using it, so...
The one I found on the web, it's huge and beyond me. Let's look at this. Okay, I'm gonna share this. Okay, here's what she gave us last week. Probably just be up here, wouldn't it?
Yeah, well, what I was using was the one where it was Pythagorean identities.
Yeah. Okay.
So I'm not sure. I'm just not sure how she got that to be 0. I mean, we're equal to 0 now just because we subtracted it after multiplying it out and doing all the work for it.
But what we got is negative 10 squared, and she has a positive 10 squared, right?
Yeah, that's where the difference comes in. Because it was 10 plus 1.
Let's see. Oh, sorry. Were you using that still?
No, you're good. You're good, man.
Okay. Well, if you need it back up, I've got it. So.
Yeah, I don't know. I don't know how. Because just all of a sudden she has it set to 0 and there's no explanation for it.
Yeah, it's just tan squared 3x minus 2tan 3x plus 1 equals. Yeah, I don't get that. So it says this equation. Oh, that's after this. So now that it's used, I can't talk. Now that it is multiplied out in order to get rid of the secant function and simplify, you should have the following. So yeah, you squared both sides, and that got us something different, right?
Yeah, and so multiplying that out gets us on the left-hand side, it gets us this equation, the tan squared 3x 2 tan 3x plus 1. But then multiplying out the secant side, it doesn't make sense. We've got 2, and converting it, so 2 tangent squared 3x plus 2. And if we subtract that, it gets us something, I mean, similar, but still completely different from what she's got.
Yeah. I'm stumped.
Yeah, I don't know.
I run up my white flag.
I don't know what they're trying to do from there. So
Hold on. Look at number 3. Why, if number 1 is all positive, why is there a negative in number 3?
That's a great question.
Because negative would bring out negative 2 tan 3x.
Right.
Well, looks interesting. Well,
Okay, so this is what I'm proposing. Forget about the let's just use substitution like number 2 says and just solve the problem that we have and just keep going and see what we get.
To kind of figure it out.
yeah.
Just figure it out.
All right, so let's move right along. So next, I guess the big thing is breaking this into 2 functions, or No, that can't be right, because we'd have more than one in this case, because we would have to. It's not a perfect square, right? Because we'd have tan 3x and tan or negative tan 3x, just so that we could get this first part. And then we need a positive, so that would be positive, negative. So positive 1, negative 1. So in this case, it would be, there's two functions. So we've got, what are we supposed to do with negative tangent?
Yeah.
So let's see, -1. So let's see.
All right, so we've got then tan of 3x is equal to 1. And then we solve for, I guess, 3x, which so tan or arctangent of 1, which would be 45 degrees, which is
Oh, it's like pi thirds?
let me go to my unit circle.
Pi sixths.
Pi over 4. You were on either side of it, so
I know.
is equal to 3x. Okay.
So
And then we need to divide by 3. What was that?
it would be pi over 12.
Yep, which is equal to pi over 12.
Okay, and then I'm guessing we would solve the other one then.
Yeah, but I don't know what we're supposed to do with a negative tangent.
I would well, if x equals something that is negative, then
Oh wait, hang on. Let me see, because we have the negative. Okay, so it would just be so you can convert negative tangent. So tangent would be negative 3x plus 1. That's according to this equation right here. So that's one of the
Or something like that.
I forget what they're called exactly.
Basic identities.
It looks like it's one of the basic identities.
Oh,
odd identities.
bring it up.
Okay. So that would be, in this case, it would just change it to the exact opposite. So negative pi over 12, which we can just do 2 pi. So 24 over 12. 23 pi over 12 would be the other answer besides pi over 12. Oh, I'm sorry. That should be, since it's negative, it should be minus negative pi. So that would be 25 pi. Okay, what does 3x equal? Be sure to get both angles. We stop here to answer the question of whether both angles are correct. By checking the original, what do we find? 3x is equal to pi over 4. What are we looking for here?
Let's see. So 3x can equal pi over 4 or 5 pi 4?
So take one side of what we just solved above, and once we take one side, solve for it in a calculator, we then compare that to the other side and see if they are actually equal.
Okay. Get my.
If they're not equal, then we know we done good, or at least that one solution that we found is wrong. If both are wrong, then we know we've done good. There we go. That's what I meant to say.
Okay.
So
Calculator go.
okay, well, it's saying that one of the solutions is false. I keep forgetting about all this stuff.
Of course, I had it in degrees, not radians.
So one of those answers doesn't fit in our equation, or that
Yeah,
equation?
well, I'm looking at the actual answers. He's got pi over 4 and 5 pi over 4 as her two answers.
So the tangent side, whenever I put it in the calculator in radians, it equals 2, and the other side also equals 2. So I think
they're equal.
They equal each other.
Okay.
So we got the answer correct. We're just not sure.
Yeah, what she did with it.
What she did with it.
All right. Okay, so the pi over 4 works. And then, and it says, as discussed in the resources on iLearn, if we are looking for all solutions, we must add either pi k or 2 pi k before dividing. Which will we add? Remember that the one solution was false, and then we can finish solving the equation. How? Okay,
So
going back to the resources.
What?
Yeah, that's what I'm trying to figure out. Give me a sec. I'm looking for an answer. Okay, that's the reduction. I really need to look over this one some more.
I mean,
Yeah.
we got one of our answers, but we're not sure what the second one means. Like, what is that?
Yeah. Okay. Do you see that the two angles are exactly pi distance away from each other? If so, this allows us to write all solutions simply as n over k. Okay, so would it be because in the I guess the equation that we're working on, since we don't have two equations that are actually pi over or that are actually pi apart, that we have to do we have to do the 2 pi over k, because that's what she has. That's my best guess, guys, by what?
Yeah, it works for me.
Because that's gonna be somewhere, just anywhere along along the unit circle.
What if the pi 2 pi k is actually is a cycle constant? Like
What do you mean? I'm sorry.
it's something I think what she's trying to say is x equals x every
Every 2 pi. I think that's what it's saying as well, because the other one in the example was there was 1 every pi k, which is what we have. We lost Zion.
Oh, great.
It's okay. Hopefully he'll get back on here.
Awesome. All right.
Okay. And I guess I solved things a little bit too early for this. So we have 3x, since we're doing the 2, we've got pi over 4 plus 2 pi over 2 pi k. Okay, and then we got to divide by 3 through both of it, so divide by 3. So we've got x is equal to pi over 12 plus 2/3 pi k.
Mm. Yeah, I think that's what it means is what I said before, where it's
Yeah.
what does the answer be pi k?
I am not sure. I honestly I can't say. I need to go through that resources thing.
Oh shoot! You mean like it's possible because we have a tangent? It's possible that it's that it cycles every pi radian instead of just only 2 pi radian.
I guess. Honestly I don't know.
I think that's what it is. Is we have to figure out which one of them is correct. We'll make it correct in whenever we try to put it in a domain.
Yeah. I guess. So.
All right.
Where did Zion go?
It just dropped out all of a sudden. I'm not sure.
Huh. Okay. Well, I've done that before, so
All right.
probably be back. So,
Okay. All right. So moving on to the next one.
The extension problem.
Yeah, I guess the actual extension problem.
so
We've
find
got,
from 0 to pi for 6 sine squared x minus 2 cosine x equals 5.
all right. So first things first is we can let's get all the bases the same. So this is going to be 1 what's the, is it 1 minus or 1 plus?
I think it's 1 minus.
Okay, 1 minus.
Here.
Yeah, 1 minus cosine.
Here's Zion. It says, guys, I think my modem overheated or something.
Okay.
Well, okay.
It happens. I'm not angry. So if you lost connection, it's not a big deal.
Yeah, I'm okay.
All right. So I guess then we need to FOIL this back in. So I've got 6 minus 6 cosine squared x minus 2 cosine x is equal to 5. So minus 5 minus 5. Okay, so that's going to leave us negative 6 cosine squared x minus 2 cosine x plus 1. Okay, so it's saying we need to find the solution set. I guess we can factor out the negative from all of this.
So, all right.
6.
It would be the same thing, so 2 cosine x minus 1.
Yeah.
And I don't think there's going to be a way to factor this perfectly.
No, it looks like we're going to need the quadratic formula.
Yeah. Oh, what formula is this that they're using here? Oh, yeah, no, that's right. Yeah, quadratic formula. Okay, so we've got negative 2 plus or minus the square root of of 2 squared minus 4, 6, 1 all over 2 times 6. Okay. All right. So we got negative 2 plus or minus 4.
I have a feeling you weren't supposed to take the negative out of the equation because I got a negative.
We have a negative 1 right here. I didn't add it into the equation, and that's where I was going wrong. So it would be 4 plus
wrong
24.
here.
Yeah, no, it wouldn't work otherwise. But yeah, no, we've got the negative that we need to
Okay,
get it to the right spot. So
that makes a lot more sense.
yeah, I was realizing that too, and then I looked out over the equation, and then it works out. All right, so now basically we just need to solve for that if someone wants to plug it in if they have a calculator handy.
Yeah.
So we're going to need a plus and I guess the 2 equations, one for the minus and one for the plus. There you go.
2 plus square root 28. 12. So for plus, I've got 0.274. That
Okay, 2.74 or 0.2. I'm sorry, 0.274, right?
0.274.
Okay.
And then let me put minus in. Negative 0.608. So 0.608.
Okay. Okay, and then it looks like we need to plug those into arc cosine.
Okay, so
All right.
let's see. I'll do the negative. Her answer is positive for some reason.
Yeah, I know. I don't know how she got that. They've got to have done it wrong.
Okay, I'm just gonna type it as if it's negative. So
Okay.
this one's 127.41.
127 point what?
127.42.
Okay.
And then
Why are there 5 extension problems in the answer key when we only have 1?
I have no idea.
I think in the answer key it's calling everything an extension problem. I was looking at that earlier. So it's the same stuff that we've been doing.
Oh, I see what's going on. Okay.
And so for arc cosine 2.74 is 74.08.
Okay. I think we need to do that in radians.
Oops.
Because there's no way.
Yeah, I'm in degrees. Sorry. Let me fix
Fine.
that. Okay. So arc cosine 0.2743. Oh, come on, calculator. Okay. Radians. Okay. Arc cosine 0.2743. This one's 1.29, which matches the answer.
Wait.
Okay.
And then arc cosine negative 0.6076. Whoops. 6076. 2.22. So it's the same as whether it's positive or negative. That's interesting.
Okay.
I wonder if she typed in the negative 0.6, but then
didn't
forgot to type
in
negative on the key.
Yeah, it must have been. All right. Next. How did she get those other 2 answers though?
I don't know. Like, is that a tweak of something? I have no clue where those are coming from. Because it's not like, maybe it's normal cosine?
It looks like it is pi minus the first x's that we got.
Okay.
Yeah, it is. So if you take pi, and subtract 1.29, that gets us 1.849.
Okay,
and
then
pi minus 2.2 is equal to 0.9178, which is her answers. So those would be.
okay. That's it then, right?
What was that?
That's it then, isn't it?
Yep, that's it. So
Wait, that's it for tonight?
yeah,
Yeah.
that's it for
We're-
tonight.
We're at the end.
It's the final countdown.
No quiz this time. Next time we'll be here till
Thankfully,
10, but
10. Yep,
midnight for
that's all
Dario.
good. No joke. We have the test to take too this week. There's a lot to do. All right. Well, I got other things to do tonight, guys. So I'm gonna
Sounds good.
say goodnight, and I will see you guys on Thursday. Okay.
All right. Sounds good. Have fun.
All right. I will.
See ya.
later.